Once again, welcome back to my YouTube channel Sriram Devarajan. Today, I'm going to solve a problem that was asked in GATE mathematics paper from the year 2014. The problem is let A belongs to M3 or B such that determinant A minus I equal to 0 where I denotes the 3 cross 3 identity matrix. It is also given that if trace of A is 13 and determinant A is nothing but 32, then find the sum of squares of the eigenvalues of A is, you have to find the sum of squares of eigenvalues of A. The problem, it was asked in GATE 2014 for 1 mark. Actually, it is given A, which is a 3 cross 3 matrix, such that one of the condition is determinant A minus I equal to 0, where I is nothing but 3 cross 3 identity matrix. Additional information for this problem is trace A is 13 and determinant A is 32. We have to find sum of squares of eigenvalues of A. Solution: since A belongs to M3R, it is a 3 cross 3 matrix. This A must have 3 eigenvalues. Let us choose the eigenvalue lambda 1, lambda 2, lambda 3 be the eigenvalues of A. Lambda 1 minus 1, lambda 2 minus 1, lambda 3 minus 1 are the eigenvalues of A minus I. This is a well-known result. If lambda 1, lambda 2, lambda 3 be the eigenvalues of A, then lambda 1 minus 1, lambda 2 minus 1 and lambda 3 minus 1 are eigenvalues of A minus I. Another result, product of the eigenvalues is equivalent to determinant. Therefore, lambda 1 minus 1 into lambda 2 minus 1 into lambda 3 minus 1 equal to determinant of A minus I. it is given determinant of a minus I is 0. Therefore, lambda 1 minus 1, lambda 2 minus 1, lambda 3 minus 1 equal to 0. If I am choosing lambda 1 minus 1 equal to 0, lambda 1 equal to 1, then I have to find remaining two lambda values. One is lambda 2, another is lambda 3. It is given trace of A is 13. Since trace of A is 13, we know very well trace is nothing but sum of the eigenvalue. Lambda 1 plus lambda 2 plus lambda 3 equal to 13. Since lambda 1 is 1, 1 plus lambda 2 plus lambda 3 equal to 13. Lambda 2 plus lambda 3 equal to 12. Also given that determinant A is 32. Determinant A is nothing but 32. It is nothing but determinant A is product of the eigenvalue. Lambda 1, lambda 2, lambda 3 equal to 32. Since one of the lambda value is 1, therefore 1 into lambda 2, lambda 3 equal to 32, which implies lambda 2, lambda 3 equal to 32. I am going to form one equation with the help of the information that I got from this problem. One of the information that is lambda 2 plus lambda 3 equal to 12 and lambda 2 lambda 3 equal to 32. I am going to form one equation with the help of this information. I am going to form one equation that is lambda square minus 12 lambda plus 32 equal to 0. This 12 is nothing but sum of the roots. This 32 is nothing but product of the roots. I am going to factorize. Since it is a quadratic equation, if you multiple, the value is 32. If we add, the value is minus 12. The possible is minus 8 minus 4. Lambda minus 8 into lambda minus 4 equal to 0. Lambda equal to 8 comma 4. This 8 is one other lambda value, lambda 2. This 4 is remaining lambda value, that is lambda 3. Therefore, the value for eigenvalue lambda 1 is 1, lambda 2 is 8, lambda 3 is 4. Here I have to find the sum of squares of eigenvalue. Sum of squares of eigenvalue means lambda 1 square plus lambda 2 square lambda 3 square, that is 1 square plus 8 square plus 4 square. The answer is 1 plus 64 plus 16. The answer is 81. For this problem, the sum of squares of eigenvalue is 81. Thank you. I will upload more videos from the question paper GATE as well as NET exam CSIR. Thank you.